So part 2 is finding segment lengths. And we really have 2 theorems, but the second one has a slight variation. Okay. So the first one has that inside intersection again, not at the center. Because if it were at the center, we'd be dealing with radii. So we'll call this A, B, C, D. A and B form a chord, and C and D do also. Okay, and there's a proportion that exists here. You guys get the result after cross multiplying. So as long as they're on the same chord, we would say A times B equals C times D. So if you have 2 intersecting chords, you can split it up into a cross-multiplying situation. All right, this next one, we're going to do 2 pictures. The first one would be the 2 secants with an outside intersection. The second one will be a secant and a tangent. Okay. And one formula, really, one big idea goes with both of these. We'll split them up accordingly in the sheet that you'll get. We'll have the individual ones, but it actually is almost easier if you remember the big idea with this. We're going to call this X, W, Y, Z. And the other one, we're going to call this X, Y, and Z. Right. So if these segments would be considered the outer part of the full segment, okay? So that's an outer, that's an outer. The reason I'm having you identify them, same thing here, these are outer. Because the big idea is if you multiply the outer piece by its whole segment on one side, it should be equal to the outer piece times its whole segment on the other side. Okay, that's the general idea. Now, what that looks like for this one, and you might want to get into the habit of representing that with one number or expression, depending on what you have. This would be X plus W, that whole segment. This whole segment would be Z plus Y. So if I do the outer here, that would be W times X plus W. So outer times the whole segment equals outer, which would be Y, times that whole segment, which would be Z plus Y. Down here it's slightly different because the outer part is the whole segment, but you would still do outer times the whole segment. So X times itself is simply X squared for this one. And then the whole segment here is Z plus Y. So the outer would be Y times the whole segment Z plus Y. Are we good on the theorems? Everyone good? So we're going to do a couple examples of these. Okay, an important thing on these is that you do not confuse these with the inner ones where you're just multiplying the little pieces. Okay. Outer whole segment. So here, you might want to make a note that the whole segment is 14. The whole segment here is 7 plus y. So for this one, we'd say 6 times 14 equals 7 times 7 plus y. Six times 14 is 84. And then you can distribute 49 plus 7y. Subtract 49. So we have 35 equals 7y. Divide out the 7, and y is 5. On these problems, don't be alarmed if you get a decimal. Some of them will end up not being whole numbers. Okay. This is one with an inside intersection. So you'd have 3 times 5 equals 7 times x. So 15 is 7x. Divide out 7, and x is 2.143. Defer to whatever the problem says for rounding, or ask. All right, and the last one we're going to do secant and a tangent. Now keep in mind, if this is the number, you're going to have to distribute. If this is the variable, you're going to have a variable squared. So we're going to actually do one with a variable squared. Okay. Again, you might want to make a note of what the whole segment is. That would be 24. So this is a case where outside and the whole segment are the same, so we would do z squared. On this one, the outer is 8, and the whole segment is 24. So z squared is 192. Take the square root, and z is 13.856. Okay. If you had a variable over here instead, you would be similar to what's going on up here where you would distribute. Questions?